Hello, Meng Lao. A very good morning to all our fellow panelists and speakers and esteemed guests, ladies and gentlemen. Of course, I like to first and foremost thank Martin Minkai for having this opportunity to speak here. In order for all participants to be able to understand, I'll keep my presentation in English, but I will be speaking in Burmese in some of the phrases, so that all is inclusive, and rest assured I won't be using any sort of complex English vocabulary in this presentation. I'm trying to make it as simple as possible. And since I'm standing between you and lunch, I'll try to be quick but very informative in terms of the overview of why do we need to think about cybersecurity for 5G connectivity, and what kind of implications, what kind of opportunities it presents to the next generation of 5G technologies, which will be widely used, they speculate, by 2022 to 2023, next 2 years, right? So it will be as common as 4G LTE today. So without further ado, I will start my presentation here. Now, before I begin, I like to highlight the fact that cybersecurity addresses on 3 different phases of an information security. First and foremost, we're looking at 3 things. It is known as CIA. That's the basis foundation for any cybersecurity. So number 1, we need to think about confidentiality, making sure data is safe. No one should be able to access the data that they're not supposed to. It is true for devices, it's true for applications, it's true for people, it's human accounts, things like that. So confidentiality is very important. Secondly, we're thinking about integrity. So integrity, what it means is that we need to be able to change the data when you're given a right permission, but you're not supposed to be able to change it. You may be able to view it, but you must not change it. So that's preserve the integrity. It could be your subscriber number, it could be your SMS messages, it could be anything, right? So it could be bank account numbers. So all of that will play in the integrity portion. The last and but not the least is availability. So CIA, right? So availability actually addresses the major concerns with availability of the systems, because without having availability, whatever you have, confidentiality and integrity will not make any sense. So 5G creates a huge bandwidth, as we all know, right? As gamers, as people who love streaming videos and things like that, and there's loads of applications that can be used. Again, that these opportunities also introduces risks that needs to be addressed. So I'll be talking about the overall. And one of the key main concept about this CIA, or confidentiality, integrity, availability, is the concept of trust. So that means it has to be a trusted BTS. The base station should be trusted. The core network should be trusted. The end user devices should be trusted, so that you can do identification and you can do authorization and authentication. So in that case, we will be going through the evolution of 5G connectivity, cybersecurity aspects, but we'll be talking very much on the basis of trust, right? Without trust, you cannot have the reliability. And make no mistake, there are operators around the world that are looking into some of the solutions providers, and they're very much concerned with the cybersecurity aspects of the 5G connectivity, their core network, how they're being monitored, how the machine learning is doing, how the lawful intercept is accepted. All of this will be playing a major role in shaping the future of 5G connectivity. So without further ado, let me introduce the first slide. So we're talking about in this massive data that is being flowing through the 5G network today and in the future. 4G already advances many of us to be highly connected. There are possible applications like video conferencing because of 4G. And because of that, it will keep on carry on this 5G from the legacy of 4G, which is speed. But it also introduces other type of applications that can be used in 5G networks. So in summary, this is from, I reference this from a World Economic Forum, because this is the go-to publications for all sort of cybersecurity and the industrial 4.0 IR, industrial revolution 4.0 related kind of publications. And cybersecurity is, of course, one of the founding pillars, or the basic pillars that all of us needs to be addressed. So number one, what are we seeing in cybersecurity? We're looking at systemic risk. the systems are not secure. That is a fact, right? A lot of manufacturers, software, hardware, anybody who introduces their systems, the systems have systemic problems. So systemic risks are there. Number two, we are looking at the capability gaps. People who understand cybersecurity are less and less, or demand is growing, but the talent pool is not growing as much. So there is a capability gaps. Lastly, leadership action. So basically, leaders of countries, departments, organizations really need to understand what cybersecurity, what role the cybersecurity is playing, and make sure that the leaders need to take action to address these problems. Otherwise, we're going to have a very eventful cybersecurity incidents this year as well. That's the prediction. Now, when we look at 5G, of course, you're looking at world's fastest. So the versus always comes in. So latency from say for 4G 200 milliseconds to 1 millisecond for 5G, and that is incredible. Data rates are 100 times improved over 4G. So I won't go into the further details, but in terms of security, GSMA, which is the go-to standard body and association that we all go to look for the the standardization of connectivity, 3G, something like 3GPP. So it is secure by design, 5G, right? And it also have the deployment models that are a little bit different from 4G. When we look at the heterogeneous, radio access networks, the 5G deployment models can be quite rapid in terms of their nature, in terms of their design. So by design, they are quite secure. Subscriber and device protection is already there. Network is also protected, of course, and technologies leveraged by 5G. There's loads of applications and technologies. It also supports the legacy generations. It also have a GSMA and 5G security activity. This publication, if you're interested, you can go to GSMA. I'll provide the link to the organizer so that you can go and check it out. Right? So now, ubiquitous connectivity. Ubiquitous means anybody, anywhere, all the devices. It could be a CCTV, it could be washing machine, it could be, I don't know, it could be anything else, right? So basically, all of the devices will be connecting to this key telecom infrastructure. We speculated that every kilometer, we will have 1 million devices connecting to that particular area. So that's huge, right? It could be rural, it could be urban, but in the condensed cities like Mumbai and New York and even Colombo, Singapore. So these are the smaller cities or with huge population, right? So Beijing, for example. So all of that needs to be considered when you think about telco infrastructure. Another one, right? So another one is the over 25 billion connected devices predicted by 2025. Now, it is the same thing as IPv4. In the past, we never thought that we will exceed 4 billion devices on the Earth. However, we kind of break the record, right? Broken the record, way past that, 20 years ago. So basically, we're going to have a ubiquitous connectivity. What it means is that there will be a lot more devices connected to the internet, connected to all your networks, and that it also includes IoTs, like IoTs that are connected. Now, for 5G, when it comes to the global economy, it will reach to about 13.2 trillion by 2035. What kind of services we're looking at? Manufacturing, 4.7 trillion. That's huge, right? And then we're going to have information and communication technology, 1.6 trillion. Wholesale and retail, 1.2. Public services, about a trillion. And the rest of it goes to 4.7 trillion. Why manufacturing? Because these days, a lot of manufacturing is, even though it is automated, it's hard for us to predict and analyze the data that is being produced. It can be a manufacturing for rice, it could be for oil and gas, it could be for water, it could be for alcohol, it can be for anything. But manufacturing in itself will use 5G tremendously in the next 15 years. Now, key applications. What are we using 5G for? What's the difference does it make from 4G to 5G? Well, the ubiquitous connectivity, again, is being highlighted here. Things like artificial intelligence, augmented reality, virtual reality, all of these applications will be used. With COVID, a lot of people want to buy stuff online, but they want to see if they're buying a watch, they want to see the augmented reality, whether it will fit on their wrist, how many chain they need to remove, things like that. So key applications are basically, it could be retail, manufacturing to everything else. So ubiquitous connectivity actually help the highly dense population around the areas like enhanced mobile broadband. A lot of people don't use, not going to be using fiber connectivities in the future. I think they're largely dependent on the 5G connectivity, especially the remote areas of the countries where the fiber connectivity is not really possible. So we'll have smart factories. You can look at the consumer, retail, public safety, communication systems, and things like smart home going to become a reality. Now, what operational capability challenges? What do we have here? We have things like segmentation and authentication become a problem because huge IoT devices are connecting. So which devices belongs to which network, right? We can no longer do things like VLAN, right? It's hard to segregate how do you categorize the threats manually? It's not possible. Right? Threat identification correlation. What kind of threats do you have? What are the normal behavior and what is not a normal behavior? What is the baseline? What is not the baseline? Is it increasing here or is it decreasing here? So these are the things that needs to be identified and addressed. Assessment and management of risk is also another problem with 5G networks because there's a huge data being generated. Security testing of the newly connected system. If the new system connects to the old system, what kind of threats or risks does it introduce? Information sharing is another challenges. Incident prevention and response. So if there's an incident these days, you can email to abuse at whatever the domain or whatever, right? And largely, rarely, a lot of people answer to the abuse emails these days, right? So preventing information because they need collaboration. Entities like Interpol will have a hard time trying to find out. They will say, "Hey, it's my microwave that attacked your web server, not me." That kind of stuff. So that will happen, right? Forensic tracing and tracking is also another issue, and validation and integrity of sensor data, whether this sensor is correct or not. Many of the times, even on an airplanes like Airbus and Boeing, sensor failures are the number1 reasons why the planes crash. So sensor validation and connectivity is going to be a key. Speaking of which, a lot of devices that are connected to the internet will start to create massive amount of data. At the same time, they can be quite vulnerable. I'll touch on that a bit later. With the EV, electronic vehicles that are up and coming, Tesla, for example, every major manufacturers, including Audi, Mercedes, BMW, they started introducing electronic vehicles, and it also they call smart cars, and that's the reason why they can be hacked. They do have security updates just like your mobile phone. It can be it has an authentication system just like a phone, because all of this needs to be addressed here. I'll quickly go through the how 5G connectivity will redefine the cybersecurity. Now, 5G applications of IoT, we talked about is self-driving vehicles, right? In the future, you're going to see vehicle-to-vehicle talking so that they won't get into a collision in the future. Can you imagine you're looking at the phone and you're driving at the same time and there's another car coming in your way and your car will automatically brake so that you won't get into an accident? This can also help companies like insurers, your insurance companies, when it says if you have a self-driving car, it needs to be insured. 5G in healthcare definitely possible, and I think that's going to be one of the key reasons why it has to be applied here. New network architecture and design, and software visualization, expanded bandwidth. I won't go into too much details here, but what I will highlight is government and regulatory compliance for 5G security is not as mature as the other compliance standards. Well, because they do not understand the implications fully yet, and we are still exploring. So that will be a major challenge. There has to be a new emerging best practices when it comes to deploying 5G networks. What kind of security features and checklists we need to be mindful of. Consumer transparency and privacy is going to be an issue. Can you imagine? People are tracking your how much heartbeat rate or what kind of blood pressure that you have on a millisecond every second on that kind of basis. So that creates an issue of privacy. Now, 5G network security is divided into multiple areas. You can see on the top right a smaller icon that 5G is a new radio standard. It has frequency bands that are shared with, of course, can share with 3G and also 4G LTE, but it does have a new, more effective and faster radio network. That's the reason why it can generate so much data and bandwidth, right? Because of the frequency that is huge and minute, they're divided. So you can see from the system-wide system-wide security, you can also look at the devices and gateways, access network, applications and cloud infrastructure, as well as identification, IT management for users, right? Now, artificial intelligence and machine learning has to be there for 5G security challenges and opportunities. It's not possible for every end user devices, many millions of IoT devices generating so much data, and you don't know which threats are there or which threats needs to be addressed and which are normal behavior. So that's why we introduce machine learning and artificial intelligence in 5G networks. Put it simply, it is not humanly possible to address all the data that you have been generated by all the devices here. Now, quickly going through the use of artificial intelligence and unsupervised learning and semi-supervised learning and supervised learning. And you can see down here what are the implications for which areas: network security, privacy, beamforming, massive MIMO, as well as network slicing. Now, the reason is that I'm going to address on the far left the column with the highlight of blue. So prediction of threat and attack based on suspicious network activity can be only done by AI. AI is the only potential possibility that you'll be able to analyze. Anomaly detection and virus and spam and classification can only be done by a supervised learning of the machine learning. Now, a lot of data is being generated from real-time data collection and feed. You can do an unsupervised learning, which means that you have all the raw data. You will have a sort of a learning model, and you will try to do graph like on the right-hand side with a scatter diagram. So you can see that normal behavior, abnormal behavior can be segregated. That's how you will label them instead of putting it into a different segment of network. So they will become like multiple labels that will be assigned to a device or a network, or it could be an activity, right? All of this has to be done by AI and machine learning. Now, 5G security concerns are there. Decentralized security, because it is an open network, it's a heterogeneous network, HETnet they call it. So heterogeneous networks will have many different type of networks come together with a standard to talk to each other. So pre-5G networks, that means 4G and 3G will be able to still talk to 5G networks. And that also introduces a decentralized part of the security, because 5G says it is very democratic, meaning you take care of your own security. We assume that you're secure. But we are open to it, right? If you're not secure, we'll block you. So that kind of mentality is there for 5G design. Now, more bandwidth will strain the current security monitoring. There's no way the current SIEM or any sort of correlation engine will be able to compete with the data, the amount of data that is being generated by this kind of bandwidth. Many IoT devices are manufactured with a lack of security. It could be CCTV, it could be a fridge, it could be a car, anything. All the IoT devices will have major implications when it comes to understanding what kind of risk they poses. Now, lack of encryption early in the connection process, that means that in the initial talking, they don't really get encrypted. Only in the later part of the conversation or connectivity, 5G will start doing encryption. So that's some of the concern as well. Now, enabling the bigger cyber threats, because we have huge network of devices, it is possible that one vulnerability, a single vulnerability, can generate millions and billions of attack. It could create botnets, botnet attacks. It could have a distributor denial of service attacks, which is DDoS. It can be a man-in-the-middle type of attacks, and it can have a location tracking and call interception, which can create privacy concerns for many users. Now that will enable bigger threats because of 5G networks. Now, how do we secure 5G then, right? That's the question. So 5G security foundations are needed in network first. So they need to ensure the network are secure first. And then all the manufacturers of IoT devices, it could be, all the brands that are creating CCTVs and the smart cars and smartphones, and everybody needs to ramp up their security efforts and make sure secure by design, right? Just like privacy by design needs to be there. And then consumer education on IoT cybersecurity is definitely necessary. Know how to use it. So how do we prepare? Install antivirus or any sort of defense mechanism for all your devices. Use a VPN to encrypt all your data. Practice a strong password security. Update the default backend passwords on all the IoT devices. Don't leave them in the default passwords, especially for network edge devices. Keep all the IoT devices updated with the security patches. Now, 5G security elements uses things like mutual authentication. So it's no longer the network actually authenticate the device. The device will also authenticate the network. So it's a mutual authentication. It is a presumed open network that's open to possible attacks from the other side. So that's why they do a lot of questioning and authentication. And it has acknowledgement for all kinds of link could be tapped. So that means they say that these are all already compromised. That's a mentality. But let's try to secure it later on. That's the secure by design. Now, lastly, this is my last slide. We'll have identity integrity protections already in 4G. However, 5G ramp it up, step it up a little bit further by introducing the encrypted subscriber IDs. 4G has an end-to-end security already. Now 5G has an end-to-end security between networks, right? So because the networks authenticate each other. Now 5G also have a unified authentication for LTE, 5G, and Wi-Fi in a single effective authentication framework. And 5G also introduced a stronger security algorithm, which is 256-bit algorithm encryption. So with that, I'd like to end my talk here. I know it's quite fast, but thank you for listening to my presentation on cybersecurity with 5G connectivity. If you have any questions, I'll be happy to answer them. Thank you.